Okay guys, since I fixed my problem with my graphic table, I want to solve these exercises and then upload this video on YouTube. Okay, so the first exercise, to solve the following definite or indefinite integrals. Okay, we start with the first integral from 0 to 1 of x cubed over 2 plus x squared dx. Okay, in order to solve it, I think it is good that we learn once and for all the division between polynomials, because it will appear in some, it has appeared in some exercise, and so I think it is good to learn it. So how can we do the division between polynomials? We have to write the numerator here and the denominator here in the right order, so x squared plus 2. Then we have to compute x squared divided by x cubed divided by x squared, just divided by x squared, forgetting about plus 2, and this is just x. So now we have to multiply x times x squared plus 2, and this is x cubed plus 2x, and then we will subtract this from this. So x cubed minus x cubed, it is just 0, and then we have minus 2x. So this minus all of this is minus 2x. So now it is already finished because the degree here is smaller than the degree of x squared, and so we have to stop. Okay, then how can we write x cubed? Well, as in the division between numbers. So for example, if we divide 16 by 5, for example, we obtain just 3 with the remainder of 1, and this means that 16 is equal to 5 times 3 plus 1. So the denominator times the ratio, the quotient, plus the remainder. Okay, and here the same thing. So the quotient times the denominator plus the remainder. Okay, and this means that the integral can be written as x times x squared plus 2 minus 2x over 2 plus x squared dx. Now we split the integral, the ratio. So we can write the ratio in this way, and we split it because now we can simplify this and this. So we obtain the integral between 0 and 1 of x dx, if we want to split the integral, minus the integral from 0 to 1 of 2x over 2 plus x squared dx. The first is very easy, it's just the integral of x, so the result is 1/2 x squared. Now we have to solve the second. Well, here we have 2x, and 2x is just the derivative of 2 plus x squared. So we can do a y substitution in this way. 2 plus x squared is equal to u, and then it means that du is equal to 2x dx, so the derivative of this 2x dx. So this is du, And we have minus the integral between, this is evaluated between 0 and 1, and we have the integral between when x is equal to 0, u is equal to 2, when x is equal to 1, u is equal to 3, 1 over u du. This is just the logarithm. So we have 1/2 x squared evaluated between 0 and 1, because here we don't do a substitution, and so we don't change the extremal. Here we did a substitution, so minus the logarithm of u, but this is evaluated between 2 and 3. Okay, if we compute this, we obtain 1/2 minus logarithm of 3 plus logarithm of 2. Okay. Now the second exercise. Integral between 0 and pi of sine x over square root of 1 plus cosine of x dx. Okay, also in this case we have that sine of x is the derivative of 1 plus cosine of x. So a y substitution can be 1 plus cosine of x. If you want, you can put just cosine of x, but if we add 1, there is no problem because the derivative doesn't change. So 1 plus cosine of x is equal to u. Du is equal to the derivative of this, which is minus sine of x dx. So, since we have sine of x dx in our integral, this is equal to minus du. We put the minus here. Okay, and we solve the integral. So when x is equal to 0, cosine of x is equal to 1, and so we have 2 here. And when x is equal to pi, cosine of pi is equal to minus 1, so 1 plus cosine of x is equal to 0. Sine of x dx, this is minus du over the square root of u. Okay. We can remove the minus and change the order of integration. Then 1 over square root of u can be written, we just saw in the previous lesson, as u to minus 1/2 du. And now we can use the rule of the integration of the power. So we obtain 1 over minus 1/2 plus 1 u to minus 1/2 plus 1. Evaluated between 0 and 2. Okay, minus 1/2 plus 1 is 1/2. 1 over 1/2 is 2. U to 1/2. Between 0 and 1. 0 and 2, sorry. So, at 2 we have 2 times 2 to 1/2. At 0 we have 0. And this is 2 square root of 2. Okay. Okay, now, so this indefinite integral of e to minus 2x over 1 minus x dx. Okay, this is a classic integration by parts. If you remember, you can use the rule of isolate. So you have the exponential here and the algebraic function here. And you remember the rule. The rule is that the integral of f of x times g prime of x is equal to f of x times g minus the integral of f prime times g. Okay, in this case, we have an algebraic function and an exponential function. So the algebraic function has to be the f because it has to be derivated if you want to use the isolate rule in order to remember. If you don't want, you have to remember that the algebraic function needs to be derivated if you have an exponential as second factor. Okay, so f of x has to be 1 minus x, and g prime of x is e to minus 2x. So f prime, the derivative, is just minus 1, and g of x, the integral of this, well, the integral of an exponential is the same exponential because we have a straight line here, not exactly x, but a straight line. So we can write the same exponential, but we have to divide by the coefficient of the x, as we saw in the two previous lessons. Okay, now we can use the rule in order to solve this. Well, we have f of x times g of x, so 1 minus x times e to minus 2x over minus 2 minus the integral of f prime, which is minus 1, so I can put just a plus here, and then g of x, which is e to minus 2x over minus 2 dx. Well, now we can solve this. Here we have, well, this minus changed the sign here, so we have x minus 1 over 2 times e to minus 2x, and the integral of this, well, this is just, well, we have 1 over minus 2 that we can put outside of the integration. The integral of e to minus 2x we computed here, so it is the same, e to minus 2x over minus 2. So, x minus 1 over 2 e to minus 2x, we have minus 2, it is 4, plus 1 over 4, e to minus 2x, plus an additive constant, of course. Okay. Okay, now we have the integral of logarithm of x over x squared. Also here, 1 over x squared is an algebraic function, and we have the logarithm. So if we follow the rule isolate, the logarithm needs to be derivated, and the algebraic function needs to be integrated, because the logarithm is the first. So I have to rewrite, unfortunately, the rule. Okay, and in this case f needs to be the logarithm, But this is natural because we don't know the integral of the logarithm, so L needs to be derivated. Okay. And g prime of x is 1 over x squared. So f prime is the derivative of the logarithm, so it is 1 over x. And we have to compute the integral, the antiderivative of 1 over x squared. Well, 1 over x squared, this integral, it is just the integral of x to minus 2. So if you use the rule, you will find minus x to minus 1. So 1 over x, minus 1 over x. Okay, so if we want to compute this integral, we use this rule. F of x is the logarithm of x, g is minus 1 over x, so minus logarithm of x over x, minus the integral of f prime, which is 1 over x, times g is minus 1 over x, so this minus becomes plus, and we have another 1 over x. So this is minus the logarithm of x over x plus the integral of 1 over x squared in dx. But we just computed before the integral of 1 over x squared. This is minus 1 over x. So we have minus logarithm of x over x minus 1 over x plus c, of course. Okay. Okay, now the last integral, I think, yes, integral of 3x plus 1 over x squared minus 4 . Okay, well, this is an integral of a rational function, and in order to solve this integral we need to have that the degree of the numerator is smaller than the degree of the denominator, but this is the case because we have degree 1 here and degree 2 here. And then when we have degree 2, so a quadratic function at the denominator, we just need to study the delta of this function. Because if the delta is greater than 0, there is a rule to solve this integral. If the delta is equal to 0, there is another rule. If the delta is smaller than 0, there is another rule. So, in this case, the delta is equal to, generally it is b squared minus 4ac. In this case, x squared minus 4, we have that b is 0, minus 4, a is 1, and c is minus 4. So we have 16. The delta is 16 here. So the delta is positive. And when the delta is positive, we can factor this quantity. In general, we have to compute the solution in order to have a factorization. But in this case, x squared minus 4, well, this is equal to x minus 2 times x plus 2. The general rule is if you have a function like that and you have to, well, not equal to 0, but we have to factor this function, we compute the two solutions. So we have two solutions, x1 and x2. then this function can be factorized in this way: a, so the coefficient, times x minus x1, x minus x2. So this is the rule in order to factor a polynomial with delta greater than 0. In this case, we don't need to use the rule because this is a difference of squares, and so we can factor immediately x minus 2 times x plus 2. Okay, so when we factor this, we want to write 3x plus 1 over x squared minus 4 as a over, not this a, another a, so we can call it, in order to avoid confusion, we can call alpha. So alpha over x minus 2 plus beta over x plus 2. Okay, and these two quantities has to be equal. Why we want to do that? Because if we put an integrate here, we are not able to solve this immediately, but we are able to solve this and this, because these two integrals are basically the logarithm. And so this factorization, this way to split this function, this ratio, in these two ratios can be very good. Okay, now in order to find alpha and beta such that this equality holds true, we need to put these quantities in a unique ratio. So we do this. Well, we have alpha times x plus 2 plus beta times x minus 2. Okay. Well, this is if we solve it, we obtain alpha x plus 2 alpha plus beta x minus 2 beta x minus 2 times x plus 2. Okay, so 3x plus 1 over x squared minus 4. Now I want to write this as a polynomial, so I just want to have x times x with its coefficient plus x to the 0, so the constant, a constant. Okay, so I have to factor x here. If I factor x, I obtain alpha plus beta times x. If I factor this and this. Then plus 2 alpha minus 2 beta over, well, x minus 2 times x plus 2 is x squared minus 4. Okay, you see now this quantity I write in this way, and in this way it is more similar to the original one. So how can this quantity, this ratio, how can these two ratios be equal? Well, the denominators are equal, so the numerators needs to be equal, and we have x times a coefficient plus a constant. Also here, x times a coefficient plus a constant. So this means that this coefficient needs to be 3, and this constant needs to be 1. So alpha plus beta needs to be 3, and 2 alpha minus 2 beta needs to be 1. If these two equalities hold true, then these two quantities are equal. Okay, and this is a system, so we have to solve this system. Here the unknown are alpha and beta and not x and y, but this is a classical system. So you have to solve the system. I don't want to solve the system here because it is a classical system, and we saw how can we solve it in the precourses. But in order to solve it, you can write, for example, alpha equal 3 minus beta, and then you substitute here 3 minus beta minus 2 beta is equal to 1. You find beta here, you substitute here, and you find alpha. I think that alpha is 7 over 4 and beta is 5 over 4 if we solve, because the sum is 12 over 4, so it is 3. And we have 7 alpha minus 5 alpha, and this is 2 alpha. Okay, so alpha it is 7 over 4 and b it is 5 over 4. Okay, and what does it mean? It means that now I write 3x plus 1 over x squared minus 4 as 7 over 4 over x minus 2 plus 5 over 4 as over x plus 2. So this, I take this and I substitute alpha and beta as 7 over 4 and 5 over 4. Together I obtain this. Okay. Okay, now this integral can be written as the integral of 7 over 4 over x minus 2 dx plus the integral of 5 over 4 over x plus 2 dx. So I put 7 over 4 outside the integration and 5 over 4 outside. Well, this is the logarithm, because it is 1 over, it is not 1 over x, it is 1 over a straight line. So, as always, the logarithm of x minus 2 over the coefficient of x, but in this case it is 1, so over nothing. 5 over 4 logarithm of x plus 2 plus c, of course. And this is the final result. Okay. So we finished the integrals. Now we go to the second exercise. So a closed region is confined between the graphs of the two functions y equal 2x to the 4 minus 1 and y equal 3 minus 2x squared. Draw this region and compute its area. And then how much would remain of this area if the part of the region below the x-axis was to be removed. Okay, so first of all we have to draw this region. It was y and y. Okay, so the region is confined between y equal to x squared x to the 4 minus 1 and y equal 3 minus 2x squared. Okay. First of all, we have to draw this region. So, this curve is a parabola and the vertex is in 0. So this is a parabola with vertex in 0. So when x is equal to 0, y is equal to 3. And the concavity is in this way, so below. Okay, this is very similar to a parabola, but this is not exactly a parabola. But if we want to write, to draw this curve, well, y equal 2x to the 4 minus 1. Well, first of all, we compute. First of all, we compute the minimum. So the minimum of this function, and this is we have to differentiate. So the derivative of this is just 8x to the 3, and this is greater than 0 when x to the 3 is greater than 0, then when x is greater than 0. So the function is, we have 0 here, and the function is decreasing and then increasing, so its minimum is in 0. And then the function increase from here to here and go to plus infinity, because the limit when x goes to plus infinity of 2x to the 4 minus 1 is plus infinity, of course, because x to the 4 goes to plus infinity. And also if we have minus infinity here, because x to the 4 is an even number, so this is positive. And we just have to compute when this function meets each other, so the intersection points, in order to do a good graph. Then, when these two functions have an intersection point, then we have to solve this system, and both of these functions of these quantities are equal to y, so they are equal each other, and we obtain 2x to the 4 minus 1 is equal to 3 minus 2x squared. Then we have 2x to the 4 plus 2x squared minus 1 minus 3 is minus 4 is equal to 0. This means x to the 4 plus x squared minus 2 is equal to 0. Well, this is a biquadratic equation. You can solve in the way you want, but you can notice that this is equal to x squared plus 2 times x squared minus 1. This is equal to this. It is a classic rule, if you don't remember. So it is this rule, I just write here, and if you have x squared, for example, plus a plus b x plus ab, this is equal to x plus a times x plus b. So you have to find two numbers that have the sum equal to the coefficient of the second term, and the product as the coefficient of the last term. And you have to write to have x squared and x, or eventually x to the 4 plus x squared, or x to the 6 plus x cube, x to the 8 plus x4, etc. Okay, so in this case, 2 and minus 1, the sum of 2 and minus 1 is 1, and the product is minus 2, and so this is good. Okay, so x squared plus 2 times x squared minus 1 is equal to 0. In order to solve it, this is a product, so a product is equal to 0 if the first factor is equal to 0 or the second factor is equal to 0. Okay, this can never be equal to 0 because this quantity has the delta negative if you want, or you have a square plus 2, it is always positive, so never equal to 0. And in order to solve it, this is just x squared is equal to 1, so we compute the square root, x is equal to plus or minus 1. So, when x is equal to plus or minus 1, these two functions meet each other. Well, x is equal to 1, it means that, for example, y, so x equal to 1 means y equal to 3 minus 2, so 1, if we substitute here, and x equal to minus 1, it is the same, so y is equal to 3 minus 2 times minus 1 square, so times 1, 3 minus 2 is 1. Okay, so minus 1 has to be here because the two functions are positive, okay, here and here. And then in order to do a good graph, okay, so the graph is like that. And this is the region. Okay. Now we have to compute the area of this region. Well, in order to compute the area, we need to compute the integral of the difference of the functions. So, the integral is between, this is minus 1, this point, and this is 1. So the integral is between minus 1 and 1. And we have to write the difference of the two functions. The first function is the function which is higher, so 3 minus 2x squared, minus the second function is 2x to the 4 minus 1. Okay. Perfect. And now we can solve. So integral from minus 1 to 1 of 3 minus 2x squared minus 2x to the 4 plus 1 dx. So this is the integral between minus 1 and 1 of 4 minus 2x squared minus 2x to the 4 dx. Well, the integral of 4 is 4x, minus 2, the integral of x squared is x to the 3 over 3, minus 2, the integral of x to the 4 is x to the 5 over 5. Between minus 1 and 1. Okay, and now you have just to compute this quantity. So you have, if you substitute 1, you have 4 minus 2 over 3 minus 2 over 5. And if you substitute minus 1, you have minus 4. So with the minus it is plus 4. You have the same quantity if you do the computation. Okay, so you have 8 minus 4 over 3 minus 4 over 5. If you want, you can compute. So this is 15, and you have here 15 times 8 is 120 minus 20 minus 12. Okay, so this is 88, I think. 88 over 15. Okay. Okay, in the second part of the exercise, how much would remain of this area if the part of the region below the x-axis was to be removed? So, if we remove this part, okay, if we remove this part, well, the question is, what is this region? So this region, it is a little bit complicated to compute because, okay, you have as limit here this, and another limit is that, but this function here, it is difficult to write the equation. So it is better to compute this quantity, the area of this quantity with the points. We compute this area, and then we do the total, which is 88 over 15, we write here, minus the integral from this point that we have to compute to this point of the integral of this function. Okay, we have to compute this point because these 2 points are different. I just want to do, okay, a zoom here. Okay, so 1 is this point here, where the 2 functions meet. This point is when this function is 0. Here. When this function is 0. And also this point. So, first we compute these 2 points when the function is 0. 2x to the 4 minus 1 is equal to 0. Well, it is very easy. 2x to the 4 is equal to 1. So x to the 4 is equal to 1 over 2. We compute the root of index 4. So we have plus or minus the square root of 1 over 2. That can be written as 1 over the square root over 2. The square root of 2. Sorry, the root of index 4 of 2. Okay. Now, we know these 2 points, and we have to compute the integral from minus 1 over the root, this root, and 1 over the root of index 4 of 2 of this quantity. But we need to pay attention, because this integral gives this area, but with the negative sign, because we know that this integral gives the area if the function is above the x line, but the integral gives the area with the negative sign if the function is below the x line. In this case, the function is all below the x line, so this integral is negative. So if we want to subtract this area, we just need to put a plus here. So 88/5 is this area, the whole area. This quantity is this area with the negative sign, so if we sum, we subtract this part and we obtain just this. Okay, I don't want to do exactly this computation because it is a very easy computation. 2/5 x to the 5 minus x. You compute this quantity and you evaluate in these 2 points and you obtain the result. It will be a weird result with some root and some fifth power, but it is a number, so it is good. Okay, third exercise. A town lies on both sides of a river, which is represented by the equation y equal to x cubed minus 3x squared in the plane. The town is crossed by a big road of equation y equal 4x, and most people live in the closer region, which is comprised between this road and the river. Find out the area of this region. Okay. So, as before, we have to write the equation. The first equation, the equation of the river, is very, very easy because it is, well, maybe, okay, this is the good graph, but we need some space to write, to draw also the other functions, so I write the equation in this way. So this is y equal 4x. This is just a straight line. Now we need to write y equal x cubed minus 3x squared. We need to draw this function and then to compute the area between the two functions. Okay. In particular, the graph of this function, it is quite easy. In particular, it is important to understand when this function it is above this line and when it is below of this from this line, because if, for example, this is the line and this is the function, if the function is like that, there are 2 regions. The first is this and the second is this. And in this case, we have to compute the integral of the curve minus the straight line. In this case, we need to compute the integral of the straight line minus the curve. So we need to understand when the curve is above the straight line and when the curve is below the straight line. Okay. So, this curve obviously is 0 when x is equal to 0. So in these points, the 2 functions coincide. But the question is, when this curve is greater than 4x and when this curve is smaller than 4x. Okay, so we have to solve this inequality. So x cubed minus 3x squared minus 4x greater or equal than 0. We factor x, we obtain x squared minus 3x minus 4 greater than 0. So we can use the same The same strategy as before, so we can find two numbers with sum equal to -3 and product equal to -4. And these two numbers are -4 and +1. Because -4 plus 1 is -3, -4 times +1 is -4. Okay. Then we have to solve this inequality. Well, we have to study the first factor, so x greater than 0. The second factor is x greater than 4. And the third factor is x greater than -1. So we have -1, 0, and 4 in order to study the sign. So the first factor is x greater than 0, then it is negative. The second factor is x greater than 4, then it is negative. The third factor is x greater than -1, then it is negative. Minus, plus, minus, plus. So, this means that x cubed minus 3x squared is greater than 4x here, because this is greater than 4x when this quantity is positive, and this quantity is positive here and here. So, between -1 and 0, the function is above the straight line. Then it goes to -infinity, because this function goes to -infinity. From 0 and 4, this function is below the straight line. So if you compute a graph, you will find that the function goes like this. So I computed before, and it has a minimum at -2, but it is not important. Also, if you do a graph like that, it is not important for the computation of the integral. So when the function is equal to 4, here, these two quantities are equal. And here the function is below the straight line, and here the function is above. Okay, so the two quantities, the two parts, the two regions obtained are these two. So -1, 0, and 4. Okay, now we have to compute the area of this region. So in the first part we have that the function is above the straight line. So the area is the integral between -1 and 0 in the first part. Since the function is above, we have to write x cubed minus 3x squared minus the straight line. In the second part, from 0 to 4, the straight line is above. So, first the straight line, then we subtract the function. So, minus x cubed plus, because we have to change the sign to both terms, 3x squared dx. And this is, well, this integral is x to the 4 over 4 minus 3x squared, it is x cubed. Here it is 2x squared. Okay. Just minus x cubed minus 2x squared. And this is between -1 and 0. Plus, and we have 2x squared here. Minus x to the 4 over 4. Plus x cubed from 0 to 4. Well, in the first, when we evaluate at 0, we obtain 0. When we evaluate at 1, we obtain -1 over 4. Here we have minus 1 cube is minus 1 with the minus plus, but it is the second term, so minus. Here we have minus 1 square is 1. 1 times minus 2 is minus 2, but it is the second term, so plus 2. And here we obtain, well, at 0 we obtain 0, so just at 4. 4 square is 16, so 32. 4 to the 4 is, well, it is 4 to the 3, because it is 4 to the 4 over 4, so 64. Plus x cubed, it is once again 64. So this quantity simplifies, you obtain 33 minus 1 over 4. So 33 times 4, it is 132, so 131 over 4. But it is not important. Okay. Okay, perfect. And so this is the third exercise. Now, the last two exercises. Environmental studies forecast that the population of an endangered bird species will be decreasing in the next years at the rate of p prime of t is equal to minus 1/2 t square root of 9 minus t individuals per year. Find out the change in population which is expected in the next 5 years. So, we have the equation of the derivative. So the rate p prime of t is minus 1/2 t times the square root of 9 minus t. So you see that the derivative is negative since the function is decreasing. Has to be decreasing because the population will decrease. Okay, the change in population which is expected in the next 5 years. So the change, now the population is p of 0. 5 years from now it is p of 5, the population. So the change is p of 5 minus p of 0. Okay. And this is just p of 5 minus p of 0. This is the fundamental calculus theorem, and this is the integral from 0 to 5 of p prime of t in dt. Well, this is natural. It is the fundamental calculus theorem, but if you have to solve this integral, you have to search the antiderivative, but the antiderivative of p prime is p. And then you have to evaluate p at 5 minus p at 0. So it is natural. Okay, so in this case, we know p prime of t, it is this. dt. Okay, in order to solve this integral, I said you that the square, a change of variable like that, the square root of a straight line, it is always good. It is always good because it will remove the square root that you have. Well, if the square root of 9 minus t is equal to u, then we compute the square, so 9 minus t is u square, and then t is equal to 9 minus u square, and then dt is equal to minus 2u du. The derivative of this du. So this integral, it is, when t is equal to 0, we have the square root of 9, so 3. When t is equal to 5, we have the square root of 4, 9 minus 5, so 2. Then we have minus 1 half, t becomes 9 minus u squared. The square root of 9 minus t is u. dt is minus 2u. du. Okay. And now we have to solve this integral. Well, I delete here, but the integral is very, very simple because it is a polynomial. So this integral is the integral between 3 and 2, so minus the integral between 2 and 3 of 1 half 9 minus u squared times u times 2u. So this quantity is just 2u squared. That can be, and this can be simplified with this. So u squared times 9 is 9u squared minus u to the 4. U to the 4, yes. So we have minus the integral between 2 and 3 of, okay, we have the u, of course, here, of nothing. So, sorry, because you can solve directly here. 9u squared, the integral is 9u to the 3 over 3. The minus, because there is a minus here, minus u to the 5 over 5. Between 2 and 3. So minus, when we have 3, we have, we can simplify, of course, here. So 3u to the 3, this is 81 when u is equal to 3, minus, well, this has to be 243 over 5, minus 824 plus, when we put 2, 32 over 5. Okay, you compute this quantity. This quantity is positive, so with the minus it is negative, but it is natural that it is negative because the change of population, the population decreases, so the change of population is negative. Okay. Okay, last exercise. So, solve the following initial value problem. Y prime is equal to, is equal to x over y e to minus x squared. Y at 0 is equal to 2. Then maybe find the maximal interval where the solution is defined and sketch a graph of the solution. Okay, good. And we have to solve this differential equation. Well, in order to solve it, this is an equation with separate variables. So I think you know what is a differential equation. So it is an equation where you have to find a function. You have an equality involving the derivative of the function itself, and the variable x. So the function, it will be y of the x, so a function depending on x, and you know that the derivative is equal to the variable over y times e to minus x squared. and the function at initial time, so when x is equal to 0, is equal to 2. Okay, now how can we solve it? Well, first we can write, this is not mathematically correct, but it works. So dy, we can write y prime as dy over dx, then x over y e to minus x squared. Well, the trick here is that it is the reason why this equation is called with the separate variables, because we can put all the variable with y in the left hand side and all the variable with all the part with x in the right hand side, and so we can separate the variable. So we can put y here, and we have y dy is equal to, well, I can put dx here, x e to minus x squared dx, and then I can integrate. Okay, this is not mathematically correct because this is a symbol, not a ratio, so I cannot multiply by dx here and here. This is just a symbol to give the notation of the derivative, but it is not exactly a ratio. But it works, so for our purposes it's good. So we multiply by dx, and we obtain y dy equal x e to minus x squared dx, and then we integrate. This works just when we can separate the variable. So for example, if I had here x plus y, it doesn't work anymore because in this case we cannot separate the variable. Or if we have, for example, e to minus x squared times y, in this case we cannot separate. So if we can separate, we use this method. Okay. Now we have to compute these two integrals. Well, this is very easy. It is y squared over 2 equal to, okay, this other integral. I just want to, in order to solve it, I want to put the 2 here. So I multiply by 2 in both sides. Here I simplify. And here I obtain the integral of 2x times e to minus x squared in dx. Why I do this? Because 2x is almost the derivative of minus x squared. So I can do this substitution. Minus x squared is equal to u. Then du is minus 2x dx. And so 2x dx is minus du. And I obtain y squared is equal to minus the integral of minus, because it is minus du, du here, and then e to u, the exponential. Because minus x squared is equal to u, so e to u, 2x dx is minus du. So I have all the terms. Okay. Well, the integral of the exponential, e to the u, is e to the u, the same. So this is e to the u plus c, and this means minus e to minus x squared plus c. Okay, I obtained y squared equal to minus e to minus x squared plus c. Now I have to understand what is c, because c is an additive constant, but in this case the solution is unique. So in this case, what is c? What constant is c? Well, we can understand it with the only information we didn't use yet. With the initial value. Okay, so we know that when x is equal to 0, y is equal to 2. So I evaluate this function. I can write this in the same way. Y, it is a shortcut to write y to the x. So I write in the extended way, y to the x squared plus c. Okay, now when x is equal to 0, I obtain y to 0 squared, it is equal to minus e to minus 0 squared plus c. Y to 0 is 2, y at 0, so 2 squared is 4, 0 squared is 0, so e to minus 0, e to the 0 is 1, so minus 1 plus c. Well, this means that c, it is equal to 5, is equal to 5. So now I have y of x squared is equal to 5 minus e to minus x squared. I substitute 5 here. And now I compute the square root plus or minus, in order to compute y, plus or minus the square root of this. Well, plus or minus, it's the question. Which sign I have to choose, because I have to choose one solution? Well, in this case, the function at 0 needs to be positive, so I have to put the positive here. If the initial value was minus 2, I have to put the negative here. So, y of x is equal to the square root of this, and this is the solution. Now we have to compute the graph of the solution, to sketch the graph and find the maximal interval of the solution, so the domain of this function. Okay, the maximal interval is just the square root when this function is defined, when this quantity is positive. This means that when 5 is greater than e to minus x squared. I compute the logarithm here. So logarithm of 5 greater or equal than minus x squared, because I can simplify logarithm and the exponential here. So logarithm of 5 is positive, minus x squared is negative, so this is always true, without computation. So the maximal interval, which is the domain, in this case, the maximal interval is equal to r. Okay, then we have to sketch a graph of the solution. So, in order to conclude, we sketch a graph of the solution. The solution is square root of 5 minus e to minus x squared. We just compute the domain, which is r. Well, the sign, it is very easy, because the function is always positive, because there is a square root. So the domain is r, the function is always positive. Then just the asymptote at infinity. 5 minus e to minus x squared. Well, when x goes to plus infinity, e to minus infinity is equal to 0. If you remember the graph of the exponential, e to minus infinity is equal to 0. So this is the square root of 5. And also when x goes to minus infinity square, it is plus infinity, and so we have e to minus plus infinity, e to minus infinity as before, square root of 5. So square root of 5 here, square root of 5 here, the function goes like that. Approaches to the asymptote. Then the derivative. So we compute this derivative, or maybe we can use, if we don't want to compute the derivative, we know that this equation, this function, solve this initial value problem. So the derivative is this. The derivative here, it is equal to x over the function times e to minus x squared. So x over the function times e to minus x squared. So in many cases, you don't need to solve the derivative. If you want to solve, you obtain this. But if you don't want to solve and you know that the solution, that the function is the solution of this differential equation, then you can use the representation of the derivative written in the differential equation. So this is the derivative. We have to study the sign of this derivative. Well, this is positive and this is positive, so if you want, you have three factor, okay, but the first factor is x greater than 0. The second factor is always positive because it is an exponential. The third factor, the denominator, well, it is also always positive because it is a square root. So if you compute the graph, you have just 0 and you have negative, positive, and you have positive and positive. So you have that the function is decreasing before 0 and increasing after 0. Okay, the function at 0, it is equal to 2. We know from here. So this function here, it is 2. It increases here, and here it decreases, then it increases. And this is the asymptote. Okay. Well, we can also study concavity and convexity, so the second derivative, but the exercise asks you to sketch a graph of the solution, not to give a complete study of the graph. So it is good. Okay, so hoping that there will be no more issues with my graphic table, we will see tomorrow.